So today we are going to be talking about how we can solve problems using angle relationships. And before we begin, there's two things that I wanted to review with you guys. So number one, naming angles. So if we look at example 1 here, this angle right here that I'm highlighting, I can label this in 3 ways. Number 1, I can look at my vertex, which is B, and I can just say angle B. The other way, I can use my other points. I can say E, B, D. Or I can go the opposite way. I can say D, B, E. Notice though that your vertex is always going to go in the middle. You could not write angle EDB. That is not an angle. Okay? So first, naming angles, you can either name it by the vertex or you can name it with the other points, but just make sure that your vertex is in the middle. Second thing I wanted to go over is just a little reminder, when you guys see an angle that has this little box here, this means 90 degrees. This is just telling you that this angle right here, its measure is 90 degrees without you having to guess. So this little box means 90 degrees, just as a little reminder. Okay, let's get started with today's lesson. So example 1 says a skewed intersection has 2 roads that intersect at more than 20 degrees away from 90 degrees. Determine whether the road intersection shown is skewed by finding the measures of ABC and DBE. So it wants us to find the measures of DBE and ABC. And it tells us that DBE's angle measure is 2x minus 10 and ABC's is x plus 35. So that's all the information that we have. So just to examine these angles that we have here, there are 2 different types of angles that we're going to talk about today: vertical angles and adjacent angles. So a vertical angle is an angle that is opposite of each other. So for example here, ABC and DBE are vertical because they are opposites. Now adjacent are non-overlapping angles, so they don't overlap each other, and they share a ray. So for example, ABE is adjacent to EBD. They don't overlap and they share a ray. So those are the differences between vertical and adjacent. So if we're looking at our example up here, we are dealing with 2 vertical angles. And the most important part of a vertical angle is that they have equal measure. They equal each other. So that makes our job here a little bit easy. Because since we know that they're vertical, we know that they equal each other, we can set those measures up equal. So we can say that the measure of ABC is equal to the measure of DBE. So let's break that down. So the measure of ABC we know is x plus 35. And we're setting that equal to the angle of DBE, which we know is 2x minus 10. So now I can just start solving here. So I'm going to start on my right side. One thing that I can cancel out or move over to the other side is this minus 10. So I can undo that or cancel it out by adding 10 to both sides. These 10s over here cancel out because minus 10 plus 10 equals 0. So I'm going to be left with x plus 45, sorry. Is equal to 2x. Now my last step, I want to, usually we were trying to get x by itself. Usually we would subtract 45. But that wouldn't really help us in this case because we're trying to get the x's together so that we can isolate them. So in this case, I'm going to subtract x from both sides. because I want my x's on one side so that I can isolate them. So the x's over here cancel out, so I'm left with 45 is equal to 2x minus x is just x. So my value of x here is 45. Now that I know what x equals, now I can actually find my angle measure. So for example, we know again, ABC, the measure is x plus 35. And we just found out that x actually equals 45. So what I can do here is I can substitute in that x. So I can say that the measure of angle ABC equals 45 plus 35. So now I know that my measure of angle ABC is 80 degrees. And so now going back up to my original question, we want to see, is it skewed? And we determine that by saying it's 20 degrees away from 90 degrees. So since 80 degrees is within that 20 degrees of 80, the road intersection is not skewed here. All right, let's try another one. So this says angle MNQ. So I have angle MNQ and PNR are vertical angles. And we want to figure out what the angle of x is. So again, remember, we know that vertical angles are equal to each other. So we can set these angles equal to each other. So I can say angle MNQ equals the angle PNR. MNQ I know is 3x minus 6. I'm going to set that equal to PNR, which is 114. So now I'm just going to solve this like I normally do. I'm trying to get x by itself here. So I want to undo that minus 6 by adding 6 to both sides. The 6's cancel out because minus 6 plus 6 is 0. So I'm left with 3x equals 114 plus 6, which is 120. Now I can undo this. Remember, when a number is right next to a variable, that means to multiply. So to undo that operation, I'm going to divide both sides by 3. These cancel out. I'm left with x is equal to 120 divided by 3, which is 40. So my x here equals 40. All right, example 2. So the next thing that we're going to talk about is how we can use complementary and supplementary angles to solve problems. So a complementary angle always has a sum of 90 degrees, and supplementary has a sum of 180 degrees. So those are two key vocab terms that you want to remember, so you might want to write them down or star these on your notes. So complementary is 90 degrees and supplementary is 180 degrees. So A says ray EG splits angle DEF into two angles, angle DEG and angle GEF. And we want to find the value of x. So one thing that we can look at here is, remember in the beginning of lesson I was telling you, this little box right here means that it's 90 degrees. So angle DEF, this angle right here, is 90 degrees. So what we know is that the two angles, angle DEG and GEF, equal 90 degrees. So now we have something to work with here. So what we can say is angle DEG we know is 3x. GEF says it's 36. And we know those together are going to equal 90. So now I can just start solving here. So the first thing I want to do is I want to subtract 36 to get that to cancel out. I'm left with 3x on one side. On the other side of 90 minus 36, which is 54. Remember, 3x is really saying 3 times x. So I'm going to divide by 3 on both sides. These 3's cancel out, so I'm left with x equals 54 divided by 3, which is 18. So my value of x here is 18. So there's really two ways you can solve this problem. Number one, you can go ahead and you could subtract 50 from both sides. I'm going to combine like terms before I do that though. So if we look in my first, on the left-hand side, I can combine that -4 and 50 because they don't have a variable, so they're like terms. So if I combine those, I'm going to be left with x over 2 plus 46 equals 180. So that just makes it a little bit simpler and less steps for me in the long run. So -4 plus 50, or really 50 minus 4, because you're adding a negative with a positive. So 46. So now I can just undo my first operation by subtracting 46 from both sides. So I'm going to be left, these cancel out, I'm going to be left with x over 2, or x divided by 2, is equal to 134. Now I can undo my division by multiplying 2 to both sides. These 2's cancel out, so I'm going to be left with x is equal to 134 times 2, which is 268. So my x here equals 268.